Everyone. We'll just start with a little bit of introductory information. There's me and there's Enrico. I'll start with me and then I'll hand it over to Enrico. Yeah, I'm John Deans. I'm a product consultant with 475, former high performance builder, certified passive house builder with FIAS. Yeah, that's who I am. So Enrico, you want to introduce yourself? Tell us about Emu.
Yeah, thank you, John, for having me. I'm Enrico Bonilauri. I'm the co-founder and CEO of Emu Passive. We started off as an architectural practice back home in Italy, and ever since we moved to Colorado in 2017, we've been focusing on passive house training. So that is most of what we do today.
Excellent. And it's great to have you with us, Enrico. This is fun. Our idea behind today's is to do something a little different, try to make it a little bit more conversational, a little more interactive too. So we're pleased that Enrico was able to join us. Um, One of the things we like to highlight is our Smart Enclosure series. So for those of you who have not downloaded our free ebook series on Smart Enclosure, you can find most assemblies in there. One thing that you will not find in there, we don't have any details around concrete-free slabs. So we have some insulated slab details and things to check out that might be useful, but this is a little bit further afield than we've ventured, and we wanted to have this conversation today because we hear about this all the time. It's becoming more and more popular. So we wanted to kind of go through what we've learned about it and what we've seen out there and some case studies that might be useful if folks are thinking about these details. In the spirit of trying to make this a little more interactive, this is how we're going to try to run things. Um, I'm going to do a little bit of a presentation. I'm going to hand it over to Enrico, and then after Enrico's bit, we're going to open it up for questions, and we're going to try to do this as live as we can. So we're going to ask folks on Zoom to use the raise hand feature, and then we're going to try to call on you as you pop up in order. And for folks who may be watching on YouTube, we're going to be watching that chat, and we'll bring those questions in. So if you have questions, put them in the chat and YouTube. And if you've got questions while Enrico and I are presenting, make a little note or something, and then we'll open it up for Q&A, and we want to try using that raise hand feature because we got a lot of folks. So bear with us. We're giving this a go. All right. So I'm going to just kind of give a little bit of backstory on this topic and kind of where we're coming from. So what is a concrete-free slab? I mean, very simply, it's an insulated foundation floor without a concrete slab. And so how do we do that? How do we create a nice solid floor in our basement, our slab on grade kind of area, but doing it without concrete? Why would we want to get rid of the concrete? These are a few basic reasons. A big one, certainly for us at 475, is we're always trying to reduce carbon, right? So the amount of carbon used in concrete, if we can take that slab section out, we've helped reduce the embodied carbon of the project. But some practical reasons that folks might be doing this is, a wood floor is a little bit softer to be walking around on. I've actually been on one that was sort of like a kid's play area, and it had even like a little bit of soft bounce to it. So, wood in general is going to absorb those vibrations more than concrete is. So it's a little bit softer. And also just nail base for wood flooring. You're in a basement space and you want to have wood flooring down there. You've got to do something to be able to fasten it, some sort of structure. So maybe you just get rid of the slab altogether. Um, one of the things we want to just sort of caveat all this is not a prescriptive presentation. This is a discussion of some of the things that people have done and some of the ideas. And it's somewhat new territory. Folks have been doing this for at least over a decade. So it's not brand new, but it is still, I think, in an experimental phase. People are still kind of approaching it in different ways. So we just want to share kind of what we've seen and remind everyone that the devil's in the details. So a little bit of history. So I know the first time I heard about this, and I think it was heavily popularized, was an article in JLC in 2016 by Steve Baczek and Steve Demetric. So Steve Baczek is an architect. Steve Demetric is a builder in Rhode Island, actually where I live. And they actually had this idea that, okay, well, we want to put wood flooring in this basement. Do we even need the slab? And then they started working through the details based even off an even older article from 2005 by Andy Engel looking at how he sort of did an insulated floor on top of an existing slab. So they took that principle and applied it to putting it directly on the stone or the aggregate underneath. So and this is a look at the detail that they had in that JLC article. But if you start searching for this on Google, there's tons of information out there, all different types of articles. So there's, Josh Salinger has done it out in Oregon, Randy Williams in Minnesota. And then Christy Weber actually wrote an article in 2023, but was talking about how she had detailed, she's an architect, and she had detailed one back in 2013. So goes back at least that far, likely further. I would love to know if anybody knows of ones that happened earlier than that. But as far as I can tell, that's kind of the history and sort of where it's all come from. So there's been a lot of folks in the space working on it, and I've seen projects in Maine, Massachusetts, Colorado, Missouri, Minnesota, Oregon, probably even leaving one or two out. So it's been sort of across the northern part of the country that I've seen most of it, but there could be examples in the southern tier as well. So just to kind of, bring out some design basics around this. As I said before, the details are really critical, especially around managing moisture, air sealing. In some ways, pouring a slab gives you a little bit of a greater margin of error. You've got something heavy weighing down your vapor barrier. You've got something that can sort of manage moisture in a vapor throttle kind of way. So, details are really critical in this. And what we hear over and over again is that the trickiest part is getting the grade nice and flat. Because when you're pouring a slab, your grade, you can have some up and down. You can be within a half inch, sometimes an inch. I've heard, I try to get better than that myself, but and with this detail, you need to have it a lot flatter than that. The tolerances are a lot tighter. And in terms of the cost conversation, happy to hear some questions on that. But from everything that I've been able to ascertain, costs are all over the place. It really depends on your team and your execution and kind of what the scope of the project is. So that's another thing to consider. So thinking through insulation, so these are some of the examples that we've seen. So there's Glavel foam glass. For those who aren't familiar, go check it out. They're a really interesting company, and it's an interesting product. So this is an aggregate that's an insulator. Mineral wool, which I'm sure folks are relatively familiar with. Foam, kind of the old standby. EPS often. And then we've even seen wood fiberboard, which proceed with caution. We'll talk a little bit more about later, but proceed with caution when it comes to wood fiberboard. But people are trying these things, right? So we wanted to just be honest about that. But there are certainly things to consider there. And then there's how are you doing this quote unquote slab, right? It's really just the floor, the subfloor that you're making. I think the most common one is a plywood or OSB double layer where they're staggered and screwed together and in many cases glued as well. But there's also 2x sleepers with subfloor on top of them. That's another way this detail has been done. So a couple of different ways to go about that. All right, so after that overview stuff, I'm going to hand it over to Enrico to kind of walk through an actual case study of a project.
Thank you, John. This is a duplex project in Englewood, Colorado. This is basically Denver. And this project it was a specs project, and the builder was leading the project, pursuing PHI certification, so Passive House International certification, which is relatively easy to do, being a duplex and being fairly compact in shape. And with regards to the slab on grade, it was the builder Peter Stewart. I'm blaming him, but he's a friend. Peter Stewart of Sterling Builders that came to us and wanted to use this kind of detail for the floor condition. I think he was familiar with the JLC order article, and he wanted to try this with the goal to reduce embodied carbon as well as I think cost was similar or slightly cheaper with the concrete less slab at the time. We're talking 2020, 2021-ish. So right after COVID. Um, and so that is what we ended up doing. You see 6 inches of foam underneath. In the next couple of photos, we're going to see the actual subfloor. The condition is a little bit peculiar because in order to limit the overall height of the building, they had to sink the ground floor a little bit into the dirt, and that's why you see the foundation walls sticking up, and only about 3 feet off the ground or off the finished floor, you see the actual 2x6 wall starting. So we're gonna see some detail later. Next slide, please. This is the floor assembly that we provided. Pretty straightforward. It's very similar to a traditional concrete with slab on grade foundation that we have. The only difference is that it's in the finish. Um, so from the bottom up, you see the gravel layer. We have a separation layer to separate the foam from the gravel. 6 inches of foam, that is what we needed to get to passive house level. This is Clemson 5, but we typically do more than that. But this being a duplex and being a larger building, it was easier to meet the full-on passive house level of performance, so we could avoid some of the insulation. And then we have 2 layers of 3/4 inch each of plywood staggered and cross-laid, glued and screwed together to be a very beefy subfloor. That is on top of a 10 mil poly. I think we ended up using a 15 mil, and that is both the vapor barrier and the air barrier of the assembly. And then on top of the subfloor, you have your hardwood finished floor. So this is all the way until and including the poly membrane. It's an identical assembly as we do with regular concrete slabs. The only thing that changes is that we avoided the concrete slab and we replaced it with the double plywood and the hardwood finish on top of it. Next slide, please. Couple of pictures here. You see the top of the subfloor. It is not taped because it is just working as the subfloor. The air barrier is the polyethylene membrane underneath. We're going to see an actual cross detail of the connection between the floor and the foundation wall in the next slide. Just, anyone working a little bit on a job site, you end up doing a lot of sketching of details. This was for the door threshold, where we had to drop the top of concrete by 6 inches in order to have the insulation over the foundation floor to install the door without them bridging. So just a couple of extra details, but this is what it looked like in real life. Next slide, please. This is a typical cross section. We're going to see an enlarged drawing of this in the next slide, but you see how the interior floor is kind of sunk compared to grade on the exterior. That was for the zoning. We had to, well, the architects, in this case, the architecture firm was Shape Architecture Studio. They had to stay below a certain maximum height, and that was drove the interior floor to be slightly lower than the exterior grade. And that's why you see the foundation wall sticking up that high, that exterior grade gets also higher, kind of in the middle of the building. That's why it is like 3 or 4 feet tall, the foundation wall. But here you see the gradient of temperatures. In the next slide, we're going to see the heat flow through the slab from the middle of the building to the outside, and that kind of informs us why insulating in the middle of the floor is so important. So in the conversation about carbon and foam here was chosen for cost considerations. I think it was also availability. This is again 2020, 2021. Mineral wool was almost as rare as toilet paper at the time. So the supply chain was kind of impacting the decisions here. Next slide, please. And here you see two pictures. On the left-hand side, you see the intensity of the heat flow, just where the heat is more intense, heat flow is more intense. And on the right-hand side, that's a representation that an architect, I like better because you actually see the intensity and the direction of the heat flow, and you see how much heat was jumping into the foundation wall, traveling downward into the soil, and then back up to the exterior air. Nothing really to do with the concrete-less slab, but it's something to keep in mind when working on this kind of details. Next slide, please. Perfect. And this is an enlargement of the connection detail on the left-hand side and on the heat flow on the right-hand side. So on the left-hand side, you see in teal light blue, you see the 6 inches of foam under the 2 layers of 3/4 inch plywood and for the concrete-less slab. And then you have the hardwood finish. This representation does not show the vapor barrier. This is just the ThermaBridge model software. And you see the foundation wall that had 2 inches of insulation until the top of the footer. And this is something that did work for this specific project in terms of passive house certification. But something that we have started to do after this is we now wrap all of our footers with insulation when we have this kind of 2x6 walls with exterior insulation, something that we would not do for a double stud wall. But again, this is not really related to the concrete-less slab. You see that once you have the insulation, the concrete-less slab works pretty well.
Enrico, I'm sure some other folks have this question too, but I'd just like to hear just a little bit more about this modeling software
Mhm.
and kind of how you get these, this arrow-based thing. It's just kind of a cool thing. I haven't seen that a lot.
It's fun, right? So this software is called Mold Simulator. It's a ThermaBridge modeling software from Europe. It's a competitor to Therm. So this representation you don't have in Therm and you don't have in Flixo. It's just specific to this software. What it does, it shows the direction and the intensity of the heat flow. The intensity is the color and the direction is the arrow. As a designer of construction details, this is extremely helpful in doing that. Unfortunately, it's a paid software. I don't know how much it costs because we purchased the license in 2012 and we've been using that ever since. So it's not free like Therm, but this kind of representation is again very helpful because it shows you where it is effective to put insulation versus not, you know. Yeah.
Great, thanks. Did you want to say anything else about that project, Enrico, in terms of things you ran into or things the build team, had to deal with or anything that kind of came up in the process?
Yeah, so that's a duplex, and it's pretty modern, so very compact form. We were able to use less insulation than we typically would in residential projects in Colorado to meet the International Passive House certification level. Um, the builder, Peter Stewart, his main feedback was that really the hardest part of the slab was to get the gravel bed to be very flat. And I think they had to laser measure with a 1 foot by 1 foot grid to get the level of accuracy. So in the conversation with gravel, for example, which we have used in the past a lot in the project we used to work in Europe, I gravel compresses a lot. You lose about 30% of the volume. And so I don't know how easy it's going to be to have the kind of level of accuracy needed for this level.
Yeah.
And you need this level of accuracy because if you're using plywood, which comes out of factory, is very, very flat, then you don't want that to be the squeaky floor that that moves. Other than that, I think the coordination with the builder is crucial because they are the ones executing this, but this was his idea. So like, haha,
Right. Yeah.
you cannot point that out on me. No,
That's right.
it was a fun project.
Nice. And I did notice in the chat, Steve Basic is in here, and thanks for joining, Steve, and said that it goes back to at least 1998 where he did a detail like this in his own house. So yeah, this isn't brand new. So our this is our first Q&A portion. So start using that raised hand feature, and first we're going to kick it over to Justin Taylor, if I can do this properly. Justin, you should be unmuted and ready to go.
Sure. Hi, thank you. Great presentation, Enrico. Thank you.
Oh, thank you.
I just had a question about the potential for heaving at the footing. Have you looked at that? I know the building code kind of has some weird wording around that, like how you would protect footings. And I'm just curious, like how if that was something that you were concerned about, or is that even something that we would addressed?
So you look up for a second. You ask about heating at the footing?
No, heaving,
Oh,
heaving,
heating.
like yeah,
Like a frost heave?
exactly, yes.
Mm-hmm.
Um, this if the concern is about the depth of the footer, this was, verified by a structural engineer, so I think they looked at compliance with that. In terms of um, frost protection, if you have heat losses, that keeps the footer warm and the ground warm. So it's kind of like not energy efficient, but it's structurally efficient in a way. So that there's a conflict of interest there, but we didn't have concerns about that, or at least that I remember. This is again 5 years down the line, but it was not really a big conversation if there was one.
Right. Yeah, because we're looking at a project where we're doing a shallow footing, and
Mhm.
it's we're insulating on top of the slab fully,
Okay.
and it's uh, because there's bedrock, we're
Mhm.
limited to our positioning relative to the frost line. So we were just a
Mhm.
little bit we are concerned about that in that project, and
Have you considered doing some skirt insulation to keep the
yeah, that's
frost
what we're
further
doing.
out? Okay,
Yeah,
cool.
yeah.
Good to
Hmm.
see you, by the way.
Thank you.
Thanks, Justin.
Mhm.
All right, we're gonna go to Paul Thompson now.
Thanks. Hello, Enrico.
Hey, Paul.
Um, we have we asked a contractor. This is for a project in South Philly. We'd be replacing a concrete slab, and we would we're looking, of course, to reduce carbon, embodied carbon, and so forth. This is a contractor that's not a pass cost contractor, but is a quality contractor that can build whatever we draw. He had reservations about the wood slab, just because he had never done it before, had never seen it
Mhm.
before, had never heard of it. Ultimately, we decided that we would try to reduce the carbon in the concrete by working with a structural engineer and keeping a concrete slab, just because of it was in the comfort zone.
Mhm.
Um, do you have any thoughts about how do you convince, or how do you inform a contractor that has never done it before that uh, there's the liability is reduced, or maybe it's not. I don't know. Anyway, he was not. He wasn't comfortable doing it. Any thoughts?
Yeah. This is a common topic for any high performance details. We see similar pushbacks with doing window install in the middle of the wall, for example, instead of the traditional Audi and other details like that. I think showing them, going to the conversation with some examples, and examples, if they can walk through the project, like physically, instead of just showing them photos, it will go a much longer way. But it's like showing them that this is not new. And I think John did a great job at looking at the history and providing context to this conversation because it's not as common as regular slabs, but it's not that rare either. Like when the builder here, Peter, brought it up, I remember projects from Europe from the 80s or 90s even, so it's not new, but having some um, like some education. I think fear goes away with more education. Um, that is like showing them that it's not that it can be done. It is done. It is done many times, and maybe it's something to get them excited about. I think that would be
Hmm.
the way to try, because the passive aggressive lever to use, in my opinion, is to kind of try to push for their craftsmanship. It sounds like this is a very proficient builder that you said that they
He
can do
is.
anything that you draw, and maybe even just have them cut out some 6x6 pieces of plywood and foam and just do a little real life mock-up and just show them the sequence. Even just that feeling and touching it may make it more real for them and engage them, and then try to get their opinion on how would you detail this. Do you like this type of vapor barrier? Do you like this tape? For example, there are vapor barrier products that I love the vapor barrier. I hate the tape. That's my personal experience using them. And so, just showing them and getting their opinion about different type of products is a way to pull them in the conversation.
If I can just follow up, I mean, if this is related to that, is I've heard people say, well, what if the plywood gets wet? And I haven't understood that question because we're going to have a 15 mil vapor barrier,
Mhm.
and it's going to be a bathtub. So, but as you were saying, you don't like the tape, maybe. Have you run into issues where that 15 mil vapor barrier has leaks at the seams? And how do you prevent that sort of issue?
So the yes, there's nothing more educational than getting some samples and play with them. I have spent the summer insulating air sealing a crawl space for the house that we ended up demolishing. So it was very much an experiment. Um, Love the membrane. The tape was really, really mediocre from the same manufacturer, meaning that it was supposed to stick to concrete, it would not. Literally, you would walk
Yeah.
by the seam and the tape would come off.
Mhm.
The a simple, I don't know, third grade experiment you can try is get a Tupperware, fill that with like an inch of water, put 4 or 5 inches of foam on it, and put plywood on top of it with a weight, and you invite them over for like an experiment and see how little moisture goes through, if it is installed correctly.
Yeah.
That visual, I think is going to be a very powerful proof. Like literally take just your kitchen container, put like an inch of water and put some foam on it so that plywood stays after it, piece of vapor barrier, piece of plywood, and a way to hold it down. Otherwise, the EPS is going to float. And that's like middle school experiment, but I think that goes a long way, you know. And that's the proof of concept. And then, of course, then it becomes a matter of how well you install it, and then you can try to bring them into the conversation, try out different tapes on that polymembrane, because the polymembrane, not every tape sticks to it. I use
Yeah.
my beloved Tescon Vana. It will come off.
Yeah.
You need a different kind of adhesive for that.
Yeah, I mean, shameless plug. I brought up a slide here that shows you can just see in the image all the way to the right. There's a little bit of a different colored tape there on the yellow Stego vapor barrier, and that's Proclima's Compigo tape. And honestly, I started using that when I was a builder, I don't know, back in 2018 or something like that. And because we had similar problems getting our vapor barrier really airtight with the vapor barrier tapes that existed, which I think were largely designed to kind of like do a decent job at
Hmm.
sealing it and then be weighted by concrete. So the whole thing kind of
Yeah,
gets pressed down. And I think that's
yeah.
kind of how they end up being effective. But we're sort of looking for a higher level of performance for these assemblies. And one of the nice things about Compigo is I mean, it sticks to poly tenaciously.
Hmm.
But it also has a little give. It's fiber reinforced, so it doesn't have a ton of stretch to it. But I don't know if folks have experienced this before. I've had poly rip off the wall before when it contracts from cold, right? So we know that there's some thermal expansion and contraction that happens, and I think having a tape that will move with that a little bit is also another way to ensure that these details get done. But this is where the details really matter. They matter a great deal because we are dealing with putting wood directly into this space. So it's a good point, Paul, and hopefully that was helpful. We got a couple more hands, and then we've got some chat questions too. So
Yeah,
we'll keep
John, do you want
rolling here.
to, there's one in the chat that was asked a bit ago.
Let's take that one, and then we'll get to the hands because I know
Yeah,
that
that
came
we
in
can
early.
totally. So
So
EJ
it's Yeah, go ahead, Rachel.
asked any opinions on using a limecrete slab. I've read that they use it instead of concrete in UK heritage buildings.
I will be honest, I'm unfamiliar. Enrico, is that anything you've come across?
I've only seen that as a radiant slab. I basically it's a filler whenever you have radiant tubing over a floor. I don't know if it would be as strong as a concrete or plywood slab for differential loads. So I
Hmm.
think you will still need a reinforcement bars, but really I think that is not the job of a limecrete slab. I may be wrong. I think it may not get to the density to be able to be less brittle, you know.
Yeah.
Uh,
Okay. We're gonna go to Richard Pansiera.
Hi, everybody. Hi, Enrico.
hey, Richie.
Hey, I just had a simple question. I'm just wondering what building inspectors say about these kinds of details. I know a lot of building inspectors they really are very conventional. You know, if they see some building, some detail that's going together that they've never seen before, they really want to know all about it. But have you had any flack from building inspectors on this kind of detail?
I um, I am familiar with pushbacks from building inspectors with passive house techniques.
Hmm.
Not really about this type of slab because it is not structural. Again, we've only done this detail once,
Hmm.
and it was 5 years ago. So my memory may be lying to me, but it is not a structural slab. So as long as there's the vapor barrier per code, I don't think they care necessarily.
Yeah. That's what I have seen online for what it's worth, and sort of looking through the discussion boards and whatnot. And I've even seen some states um, doing their own sort of articles for inspectors or for, builders on sort of proper execution and stuff too to help inform that. So I mean, obviously it's, the building inspectors have to have access to that education, but I haven't heard of a lot of pushback. And I think like with anything, when you're doing something new, you got to plan ahead and have a team approach and bring people along with you. Always best not to spring a new idea on someone who's maybe unfamiliar with it. So yeah, thank you for that.
Yeah.
Donna Nuriel.
Hi. Um, Forgive me if my questions are stupid. I'm just learning.
No, no.
So, thank you. So you mentioned footings. That's what's anchoring the house to the ground? Are they concrete?
Yes.
Yeah, I'll go back a little bit, Enrico, so we can
Yep.
you can talk. Oh, skipping on me.
So yeah, if you see the left image with the
Oh
circle,
yeah. Sorry, I missed that.
you're good.
No worries.
The brown is the dirt, and then the big rectangle, horizontal gray rectangle, that is the footing, and that is where the weight of the house sits on the floor on the ground.
So it's essentially a post and beam house, but without the elevation or the crawl space underneath?
Now the post and beam is you have posts which are individuals, isolated foundation points. This is a continuous wall that has a continuous. It's a reverse beam in a way because it is distributing the weight of the house from the continuous wall, the condition foundation floor wall above to the ground. So that is a continuous um, rectangle of concrete that takes the weight from the foundation wall and distributes that over the ground.
Thank you.
Of course.
Yeah, great. Please, everyone, feel free to ask whatever question comes up because we want to make sure people are getting what they need out of this. So, do we have any other chat questions?
It looks like someone just asked one here. Dan Loeffler, if you're able
All right,
to.
yeah, I see that now. Okay, so are interior column loading and differential movements a concern for vapor and moisture?
So the starting from the differential movements, because that happens with or without the interior columns, those differential movements do happen. And so it's more of a concern that when you have elements meeting it at an angle, like your foundation wall meeting your slab, or your point steel stud or column in the middle of your floor meeting your floor, those are penetrations, and you want to seal them. For air and moisture, and those sealant, whether it is tape or caulking, you want them to be flexible and to remain flexible over time, so that they will be able to adjust to the settling. At the foundations, this settling can happen mostly during construction because the ground is receiving the weight of the house. There's also some seasonal shifting because the ground is more or less moist depending on the season, and to some extent ground with some moisture is more able to carry load than very dry dirt. So there is a sweet spot there. And if the moisture changes over, but that can vary a lot depending on your climate and on your ground. So that is hard to make a one single passing statement.
I'm just gonna,
Sorry, go
oh, go
ahead.
ahead. Well, I was just going to bring in from the chat too. There's a bit of a conversation going on here, but some good points that it's not only about the managing the moisture coming from the outside, but also being, the contingencies around leaks on the inside. And so Steve Bazek is giving an example here that the project that he and Steve Demetric did have a water heater leak. The basement flooded with 6 inches of water and was pumped out, and the Advantech was able to be dried. So obviously there's going to be some sacrifices potentially with finished floor material, but that's bound to happen with floods anyway. So that's the other thing to be thinking about with these. So we've got a couple more questions here. Baron Santos.
To add a comment to that, I think
Oh, sure, Enrico.
also depends on the type of engineer board you're using, because Steve mentioned the Advantech boards, and those are very impervious to water. You see pictures on Instagram with the subfloor above grade being exposed to water for a long time, and that is not a problem. It would have possibly been a problem with just regular OSB, because that is a lot more subject to soaking up moisture and being deteriorating from that.
Yep.
So there's a little bit. If you're concerned about that, you may go with a product like Advantech instead of using a cheaper OSB.
That's a great point. Baron, go ahead.
Hi, John. Hi, Enrico. Thanks for this
Hey.
presentation today. It's been
Yeah.
very informational.
Yeah.
I had a question for you. I don't know if you've come across this or anything. This is obviously new to me, but I've got a project coming up in the next couple of years that's in the planning stages now, and it's going to be in an area with a fairly high water table. And I didn't know if you had any information how something like this would perform in an area where you had a high water table. Thanks.
That's a great question. I think I will start with having a plan for your drainage,
Yeah.
Because Steve put a great comment in the chat earlier. Because if your water strategy is the taping of the membrane, you have failed at your water management strategy. So I think looking at the big picture, if you have high water table, you want to be very confident with your ability to drain, and then you're able to use this kind of detail.
Yeah, I'd just add to that. I mean, I always really encourage a team approach with these things, and part of the team member might need to be, civil engineer, someone who can study those, the hydraulic pressures and help figure out exactly what Enrico's talking about. And I think Peter Bowering in the chat earlier said, just to bring up engineers, that if you get an engineer stamp on this, then the building inspector is probably not going to have an issue with it. So that's another thing on that aspect.
Great. Thanks, guys.
Thank you. Yeah, appreciate it. Gene DeJoannis.
I've read that one of the functions of the concrete floor slab is a structural feature to resist the inward pressure from the earth on the foundation walls. Can rebar substitute for that, tying it into the footing with rebar?
So that is true for basements mostly. If you have this condition, for example, the slab was sunk compared to the exterior grade, but only by like a foot or two. So the push from the ground was not significant enough for the building to need a concrete slab. If I think better or more rebars at the foundation wall can do as good. And so you could avoid that, but I'm not a structural engineer, so I think that depends on the details of the building you're designing.
Yeah. And I think I mean, another reinforcement for having an engineer involved if some of that sort of diaphragm support is what you need. So we're going to hold questions for a second. We're going to try to get through a few more slides here, and then hopefully still have a minute or two at the end. So I had some other project examples to just share, so folks had a little bit more visual reference to the approaches that folks have taken. So Peter Bowering, I think, was with us at one point. This is his project. He was willing to share these with us, so thank you for that, Peter. So this is looking at his approach. What I particularly thought was a clever thing here was sort of you can see that pipe in the middle that he's using as sort of a screed guide to help with that leveling. And he's obviously using, I think, at least like a 1/2 inch stone there as a sort of topping layer that's a little bit easier to smooth out. So he's compacted his normal 3/4 stone and then is using a finer stone on top of it. So those screed points are really interesting. And I don't have pictures of it, but Steve Demetric has actually talked about how if they're dealing with a very, very, big foundation, they might actually pour just like a one concrete beam down the middle that's even with the footings and allows them to have a screed guide. So having screed points, thinking through how you're going to level this thing and try to make it efficient is one of those things to really consider. And then of course, this just kind of helps show the layers where you've got the flattened stone, and then in this case, EPS foam, the vapor barrier, and then that first layer of Advantech. And some more shots just to kind of show it in progress here. And I wanted to kind of highlight, this is just one example, but thinking through these details, where are the potential, what sort of odd situations are you going to run into? This being, a partial retrofit, or it's an addition onto an existing building. So it had this, chimney to deal with. And so this is using a liquid flash material to connect that layer there. And then on the picture over here on the right, there you can see the vapor barrier that is connected to the outside in this case, I believe, as the sort of connecting that air control layer underneath the the bottom plate. So leaving a little bit of that hanging in preparation for this, and then making that connection there. And then obviously, ceiling penetrations. So some of this is going to be the case no matter what you're doing on top of your vapor barrier, but good to kind of see these things. And we can see on the left-hand side how you get that double layer, again, in this case, Advantech, where you have the Advantech going one way, and then you want to try to stagger those seams the other way and send it in the opposite direction. This one, So I put big caveats around this. So I talked about wood fiber earlier. So this is Gutex wood fiber. This is a project up in Maine, and it just reinforces how much you really need to have plans and the details around, potential moisture management. If everything stays dry, it should be fine. But obviously, if you do have, a leak, or if your vapor barrier is not perfect, then this could be a real issue, having a bio-based material, sort of sitting potentially in water for long periods of time. So certainly approach this one with caution, but I thought there was some nice details in terms of kind of the installation itself. So looking at the edge here, what they decided to do was actually kind of create this 2x curb to help fasten the first layer of subfloor in, and have sort of a nice hard guide there along the side. And then another thing to consider when you're looking at your team and your project is what are the materials that are going to be dealing with this floor. And so there's a bathroom here, so this picture on the right sort of shows an area that does not have this, and they're actually going to be pouring a small slab because that's the shower and tile, and they had large format tile here, and the tile company was like, we're a little bit concerned. We don't know if this is going to work or not. And so they said, okay, well, this section, we're going to pour a little slab. So we make sure that we've got a nice, surface for that large format tile. So thinking through those details ahead of time is obviously a critical piece. And then, thinking about, like, if you have a pipe burst, if you have a water leak, taping the seams on the top level can help mitigate that, help make it so that you don't have potential, future, water going down into those cracks. And so that's another sort of safety measure. And in this case, they don't want to tape the floor fully during construction, but where they're putting walls, they're putting a small leader piece of tape under there so they can connect to that, right before flooring goes in. So just some other things to consider. And we've got the Tescon Vana tape connecting to the Exoseal Finnock in this case, which is the capillary break under the sill, and also a continuation of the air sealing. So just some nice details here to look at. And then, these are all available online. I encourage people to go read these articles: JLC, Journal of Light Construction, Fine Home Building. There's great articles that go along with these, but I thought I'd just sort of show that there are some details out there online that you kind of help you envision this. And in particular, we've got this one over here. This is from Mike Main's, doing the sleeper and subfloor approach. So a little bit of a different approach. Instead of kind of making just this monolithic, subfloor slab, this is using sleepers and then fastening down to those. So, just a different approach, another way to kind of go about this, and wanted to make sure that option had a little bit of airtime as well. That's Enrico's detail again, and then this one's in Green Building Advisor, Fine Home Building. So this is I just thought this was a nice cutaway, kind of showing how all the layers come together there. So I just wanted to sum up a few things we've talked about, and then maybe we'll have time for one or two more questions if folks have them. But I kind of think about this in terms of sort of 4 major layers to consider and to think through. So I'm calling this one the aggregate or the substrate. So what are you going to use? Are you going to use stone? Are you going to use a couple of different types of stone? Some folks I've heard of have put like landscape fabric and then use sand to try to get a level surface. I've heard there's mixed results there because it shifts, it doesn't compact well, but you can still get something sort of flat. So thinking through what your substrate's going to be, what kind of aggregate you're going to use. If you're using something like gravel that is an insulating aggregate, that is a very large format material. So it comes in really big chunks, basically. So really hard to get flat. So you got to have a plan to sort of be able to top that or get that flat. But that can provide some of the insulation. That project that I showed with the Gutex wood fiber actually has gravel underneath it as the main insulator. So that's a foam-free slab, which is kind of a cool feature, again, with the caveats. And I think the biggest thing to drive home that I have heard from pretty much everybody who's done this is it takes a lot of time to get it flat. You got to get it flat. That's really, you should just expect that it's going to take a lot of time to get it flat. Do the best you can to figure out how to approach that so you get something uniform. That's where you're going to spend time. I have been on at least one where, you know, they definitely had some like weak spots or high spots, and your insulation is unlikely to conform well to that. So that's definitely worth planning for. Insulation, again, just think through what you're going to use, how it's going to go. Again, if you're interested in wood fiber, tread lightly, young Padawan. I wanted to bring this up too, is sort of where is it in relation to the vapor barrier? Most of the details you're going to see is going to have that vapor barrier underneath the subfloor. One of the risks there to just be aware of is you got to make sure that you're not using fasteners that are going to go through. You're not overdriving fasteners and kind of creating holes and punctures in that. So for instance, one of the things that I meant to mention, but I'll mention now about the wood fiber one that I liked as a detail was there's glavel, then the vapor barrier, then insulation, which is also making it so that any fasteners, aren't an issue. They're not going to drive down deep enough to affect that poly vapor and air barrier. So just thinking through those details and how you're going to approach them. I think some folks have done, a couple layers of foam, the vapor barrier, and then maybe one layer of foam. So there's going to be pros and cons. That's something to work out with your team, but just something to be deliberate about. Which I just got into that. I highly recommend a 15 mil plus vapor barrier. I mean, just having something that is going to be robust. It might be seeing more sort of damage or abuse, or, it might just, you just want something that's going to be very durable. So I'd recommend 15 mil plus. You need to tape it perfectly. So, managing vapor getting into this floor system is really critical. So also when you tape it, make it perfect. Both things should happen. You don't want fasteners to pierce it. Choose the right length. Don't overdrive them. And also, I strongly encourage perfect taping. Just to drive that point home. For the slab, we kind of went through this, but the typical one is 2 layers of subfloor. I've heard people talk about gluing it, and I've heard people talk about not needing to glue it. So those are conversations to have. Gluing is certainly going to give you that much more, but there are potentially arguments to skip that step. So something to talk about again with your team. Sleepers and subfloor. I know that that wood fiber project, actually, the other one that they did, I just don't have photos of, is they kind of did some A/B testing, and they did that slab in the ADU, and then in the main house they actually did sleepers and plywood or in one layer of Advantech. And conversation with the builder was sort of like, it's 6 of one, half a dozen the other, because you still got to get something pretty flat, and you have to shim your your sleepers so that those are flat. So there's a lot of work involved in the whole flat part of this. Concrete is a liquid, and we know how to get it pretty level, and folks are good at that now. This takes a lot more care. So just be aware that there's no easy way out, basically. And I recommend taping the joints in case of emergency, having that backup in case there is something that happens inside the home. So we've got just a couple minutes left, and we do have a couple hands. So I'm going to hand it over to Chris Spychelski. Maybe I got that. I probably didn't get that right, but
yeah, Spachelski. Yeah, that works.
Yeah,
There's a couple of low carbon cement alternatives like Sublime. Wouldn't that be the best of both worlds? And how would you compare that to this? And do you have any examples of cost and incentives, rebates to help encourage people to save carbon?
I'm not familiar with that. Enrico, are you?
I'm not familiar with the product. I know that there are research projects that are bringing low embodied carbon cement to the market. I don't know the specific product. I know that some jurisdictions are starting to require or capping how much embodied carbon you can have in projects. I'm thinking of Boulder, the city of Boulder in Colorado, that is pretty progressive in that regard. And for any city-funded projects, I think they have a cap on the embodied carbon that you can use, but that is not an incentive. It's the stick, is not the carrot.
Mhm. Great, thank you.
Yeah.
I encourage folks to go into the chat if you haven't, because I think it goes away when we're done. So there's been some good conversation in there, but I want to get at least one last question in here. Brad Robertson, go ahead.
Yeah, I just wondered if you guys have ever seen this done with a crawl space, so where your floor is not directly on the vapor barrier. You know, you've got TJIs or something above it. Do you need to put down something hard on top of that vapor barrier? Like the Stego is pretty strong. Well, I've used it before. Can it just be left as that?
Yeah, we've done it that way many times. The only time, like sometimes, if you have some mechanical equipment that needs to be accessed in the crawl space, you may just leave some like a
Sure.
pathway of boards so that that does not
Yeah.
get damaged. But in the crawl
Yeah.
space, you would have your vapor barrier exposed.
Yeah. Okay.
Yeah, to add that, I know at least of one project team who kind of went down this road and in retrospect wish what they had done was just to frame a floor right over the top. So not even a crawl space, but just actually have the whole plan so that there was room to just put floor joists down and do that over an insulated, with vapor barriers. So, I think this all comes back to it's all. I said I think this isn't my last presentation, but it's all like the adult diapers. It depends. So we're at time. And I just want to thank again Enrico and Emu. If you're not familiar with Emu at all, please go check them out. Great passive house trainings and consultations. So definitely hit them up. Enrico, thanks for joining us. Thanks for everybody for jumping on. We're really enjoying this ability to interact with you all.
Thank you so much for having me, and thank you all for being here. That was a great conversation.
Thank you, guys.
Thanks a lot.
Thanks so much. Hope everybody has a good day.